So, just a relation is a set of ordered pairs, x, y, where x is the input value, y is the output value. Okay? And so sometimes we're given like what the relation is, and sometimes we're just told here are some numbers that are related. So for example, right here, it looks like we just have 1 and 4, they're related, 2 and 8, 3 and 12, 4 and 16, and they're all related as ordered pairs. We actually were given a context here. It was the number of whole wheat cracker boxes sold. Those are our X's, so 1, 2, 3, and 4. And then the money that was earned from selling those boxes, so $4, $8, $12, $16, so on and so forth. Okay. We then took that, remember we put into a table, we graphed them. That stuff's like old hat to you. You've been doing that probably since you were in elementary school, right? Then there was another situation here with like ages and heights, and we paired those up too from a previous problem there, okay? And we also stated the domain. Again, the domain are your inputs, the x values, and the range are like the y values, your outputs, okay? You can also think of in terms of independent and dependent variables, okay? We'll talk more about those later, but the independent match with the x's, dependent match with the y's, stuff like that, okay? With relations, and so here's the new stuff now. So if you tuned me out because you're like, I got it, Mr. Widmeyer, tune me back in now, okay? Because we are going to talk now about functions, okay? And what a function is. Okay, a function is a type of relation. So you have this bigger umbrella term, relation, just showing that two numbers are related. A function is a special type of relation, okay, in which there is only one output value for each input value, okay? So one output value attached to each input value, okay? So in other words, every x goes to one y. Every x value is paired to one y value, okay? Or in other words, for every input value, there is a unique output value, okay? So for example, with the relation y is equal to x squared, when x is 3, well, what is 3 squared? 9. So when you put 3 in here, you always get 9, and only 9. There won't be some other number that when you plug the 3 in here, you get another number besides 9. It will always be 9 when you plug that in there. Okay, that's a representation of a function. Okay, so let's take a look here and see. So give the domain and range of each relation, state the corresponding outputs for the given inputs in context, and explain whether the relation is a function. Okay, so this one's an example. We're going to go through it together, and then we'll do one as well, filling it in and stuff. So Josh, you made it. Good. Thank you, sir. Okay. Josh, we are in our books on page 116 right now, okay? All right, so let's take a look at this. The given relation represents the number of students and the number of classrooms the school has to have for the corresponding number of students. Wow, that is more confusing than I think it needs to be. So basically it's like, if you have this many students, you have to have this many classrooms. If you have this many students, you have to have this many classrooms, so on and so forth. Okay? So the domain for this situation, all right, and I know it's written there, but I'm going to still pick someone here. So Sean, according to this table, what will our domain be?
Domain.
Yep. What's the domain according to this table?
40, 45, and 50.
Yeah, perfect. Exactly. And it's also written just right down there. But that's exactly right. Good job, Sean. Yep. And so then what's the range? Tyler, C. What's the range according to this table?
I would say it's about like 48. Like two. Makes 48.
The range, I'm not talking about the range like mean, median, mode, and the range. I mean like the ranges in the y values. What are the y values according to this table? What are the outputs? 2, 3, 4. Yeah, there you go. Yeah. Yeah, we do use that word range in two different ways in math. So for functions and stuff, we're talking about range, we're talking about the y values. But range can also be like the difference in the highest and lowest, values and stuff like that. So I see what you're getting at there, yeah. But it's just the y values for our case. Okay? So 2, 3, 4. All right, cool. And so then you'll see here some other stuff. So they also said state the corresponding outputs, or corresponding just means matching. So state the outputs for the given inputs in context. So for example here, 40 and 2 match. So what they're trying to say is for an input of 40 students, there's an output of 2 classrooms. For an input of 45 students, there's an output of 3 classrooms, right? And then for an input of 50 students, there's an output of 4 classrooms. Okay? Is this relation a function? Does every x value go to only one y value? Does every x value match to a unique y value? What do you guys say? Look at your table. Yes, it does, right? 40 matches to 2. 45 matches to 3. 50 matches to 4. So 40 is not going to 2 different numbers here. 45 is not going to 2 different numbers. And 50 is not going to 2 different numbers. They all match to a single number. So is this a function? Yes, the relation is a function. Okay? And you can see here's like here's a mapping right here. They took the 40, paired it to the 2, 45 to the 3, 50 to the 4. Okay, so this is a function. Let's continue on, though, to the next one. Question.
This relation is a function. Can you just, so I have a comparison point, tell me when it wouldn't be a function?
Sure. So, well, can anyone come up with a way that this would be a function? What's another point we could put in here that would make this thing not a function? So, yeah, Kaden? The next one we're going to do is not going to be a function?
No.
Actually, that one will be. We'll talk about why in a second here. I see what you're saying, though. You're seeing because the 16 and 17 both go to the 250 or whatever they 240, but I'll talk about that one in a second. Okay? So again, to make something a function, it's got to be one x going to 2 different y's. One x matching to 2 different y values here. So how can I make that happen? If I put in a point, like right here. If I put another point right here, okay, what would the coordinates for this be? Actually, let me make it easier. Let me put it right here. What would the coordinates for this point be right here if I put that in? Not 140. 40, comma 1, right? So I put in my table right here, like this. And do you see the issue now? I have the x value of 40 being paired to 2 different y values. Okay? So x value 40, 2 different y values it's paired with there. All right? But let's move on here and see, because again, I want to talk to what Caden had to say there, because it's a good point that he brought up there, okay, whether he wanted to or not. I'm glad he did. All right, so let's look here. The given relation represents the amount of gas in gallons and the distance traveled in miles from that amount of gas. Okay? So, 10 gallons of gas, 150, so on and so forth. You see that, okay? There it is graphed. There is the mapping here, okay? We'll come to the question of a function in just a second. Let's worry about the domain for right now, okay? So let's go to Mark. Okay, Mark, so given our table here, what is the domain of this relation?
10 and 150.
Okay, so 10, yes, no to 150 though. What else? 10, 16. There you go. You got the right idea. It's just all the x values, all the first column there. Okay? And so, and what does the domain represent in this case? The what? What's the heading there, Mark, for the domain?
Gas.
Yeah, gas. Yeah, gallons of gas. Okay, that's it. Oops, I should probably go to my red pen now so that way it shows up better here. Sorry about that. A better contrast than my gray pencil against the gray background of the page. All right, very good. Let's go to Reagan then. Reagan, what is the range of this relation? So Mark just gave us the domain. He said 10, 16, 17, 20. What will the range be? What numbers are in the range? Okay, and so what? Give me name off the numbers for me, please.
150.
Uh-huh.
240.
Uh-huh. And so, do we need to include the 240 twice for the range? No. If you want to include it twice, I'm not going to, say that's wrong, but we normally don't have to do it more than once in the range. We're just listing all the possible outputs. Okay? And sorry, Reagan, you said this already, but could you just say it again? What does the range represent? The distance in this case, yes. No, that's okay. You said it already. I know I was making you repeat something you already said. Okay? We are not going to do this because I think it's kind of silly. Okay, so we're going to skip those parts. But we are going to say the last part. This relation, blank a function. Carson, what do you say? Ooh, not yet. Dylan? Bathroom 2? You guys get me so excited sometimes. I'm like, oh, they want to answer the question. And then it's like, can I go to the bathroom? I'm like, oh. But yes, you can go to the bathroom. Just let's finish this problem first, okay? this relation is or is not a function? Sky, what do you say?
You already said it was.
I already said it was?
You already said it is a function.
I did say it earlier, didn't I? It is a function.
There's my reasoning.
Well, you know what? I'm glad you trust me. Thank you. Each domain value is paired with how many range values? It's kind of a clue in the fact that it says each domain value is paired with blank range value. It's got to be 1 then, right? For it to be grammatically correct. Sorry. Each domain value is paired with 1 ranged value. Exactly 1. Oh, I see what you're saying. I see what you're saying. It should be exactly 1, I think, yeah. So let's go back to what Caden said earlier, though. So Caden noticed that the 17 and the 16, they both are paired with a 240. That does not mean this thing's not a function, okay? Remember, how did it fail over here? It was that the x value of 40, the same x value of 40, went to 2 different y values. Here, it's not the same x value that's being paired, it's the same y value that's being paired. So it's okay in the other direction. It's okay to have 16 go to 240 and the 17 to go to 240. It's not okay for the 40 to go to 2 and to 1. So 40, the single x value of 40 should not pair to 2 different numbers or more. Right? Here, all these x values are paired once. Okay? Now, if I drew in something like this, if I said the 20 went to the 300 and the 20 went to the 240, now it's not a function because the 20 is going to 2 different numbers. Okay? That makes it not a function. Okay?
So if y goes to x, then it's not a function, but if x goes to y, then it is one?
If 2 x's go to 1 y, I'm sorry, if 2 x's go to 1 y, that's okay. If 1 x goes to 2 different y's, not a function. Okay, it's a little bit weird. I'll show you here an example. So, but just for some practice, I'd like you guys to go ahead and do number 3 here. Okay, so here's what I want you to do. I want you to give the domain and the range. Okay, don't do the interpret in context part. You can forget about that. And we can also forget about the state, the corresponding outputs as well. So in other words, just give me the domain and range and then explain whether the relation is a function or not. Okay? Explain whether the relation is a function or not. Okay, and just do number 3. Just do number 3. Okay, we'll make it very easy. So domain, the range, and then, yeah, Carson, you can go to the restroom now if you want to. Okay, and then Dylan after him, okay?
So I'm going to take Catherine.
We will, yes. It's going to be. Let me see. I gotta figure that out.
When is this class go till 5 o'clock?
No. It goes to 11:10.
Oh,
Yes, we have some time still.
we have time.
Yeah.
But I am taking it early.
Understood. Yes. I understand.
Okay.
And then I'll get you the. Yeah, we should. Hopefully, we'll be to it by that point. Before. You know what I mean? Before you go, we should be working on it by that point.
Gotcha.
We only have like one more thing I have to go over. So. Okay, so again, identify the domain, identify the range, and whether it is or is not a function. Oops. Sorry, folks, I'll get that door there. Alex, question?
I said, should I tell the answer?
But yes, I'll let you say it. We'll get her on. Say again? Yeah, we're continuing. Yeah, you're good. Yeah. Anyone still need more time? Looks like we're good. Okay. All right. You guys are getting this? That's good. Let's go. All right, Tyler L. What do you say, Tyler L? What is the domain for this relation?
2, 3, 4, and 5.
2, 3, 4, 5. Sounds good to me. Very good, Tyler. And then let's go to Shepherd. Shepherd, what's the range?
4, 6, 7, and 9.
Beautiful. Okay. And of course, in the context here, I know I didn't ask you to do this, but what is the domain representing in the context here? Let's go to Kendall. Kendall, what's the domain representing in this particular problem? Books sold. And what's the range representing, Kendall? The price. Okay, good. Yeah, again, it's just the column here. Books sold. Price, right? It's just those columns where you got the numbers from. Thank you, Kendall. Kendall, would you also... Oh, actually, you know what? I told Alex he'd do this one. Alex, is it a function, yay or nay?
I said nay.
You said nay, good sir. And that's... Wait. Are we okay with this?
Is it?
No.
No.
It's not repeating, so it is a function.
Every x value goes to how many y values?
One.
1. We're okay with that.
Oh,
Yes. Okay, it is a function.
And
I
it's
couldn't see the pattern between the x and the y value, just regularly.
Oh, I see what you're saying. So there might not be a pattern. I see what you're saying. There might not be a pattern, but it can still be a function even if there's not a pattern.
Can you explain like the difference between a function and what's not a function?
Yes. Okay. And actually, give me, well, all right, I'll do it one more time here. Yes. And so a lot of the times in math, we kind of like, there's a very clear reason why we distinguish between things. All right. It's maybe not so clear here why we take something that, okay, we relate numbers, and then why we go into this very specific subcategory called a function, okay? Functions are important because if you can imagine, if you plug something in to a computer or to a machine or to like a function, okay, if you plug something in, you expect a single output, right? So like if you press a letter, imagine pressing a letter on a keyboard, okay? If you press the H letter, what letter do you expect to show up on the screen? H. If H or K could show up, that would be a problem, right? That's like what a function does. Your input, you press the H button, and on a function, the H could go to K or to H on the screen. So you see what I'm saying? That's kind of the issue that we have. So functions are special because when you press H, you know you're going to get one output, and it's going to be that H. That's what a function is, okay? So when you have your domain values, every domain value is paired with one y value. You don't have to worry about getting possibly two y values with it, okay? Yes. Does that help, Alex? So let me show you. So this is a function. Let me show you again how I can make it not a function. I'll do it real quick here as well. So for example, let me just throw in. I'm also going to have the point 5 books sold will result in a price of $10. Okay, so I'm going to add this point in, which means down here, I can still keep that 5 there, but I'm going to have a 10 as well, and the 5 is going to pair with a 10 as well. Okay?
So
Do you
that
see how this is
not a function?
not a function?
So if there's like, let's say there's a 2 and there's, for the 2 you have 4 and 6, then it would immediately not be a function.
If you have 2, 4, and then like a 2, 6, exactly, because that x value 2 is paired with 2 different y values. Which again, kind of makes sense. It's like, wait a minute. If I'm buying 2 books, I shouldn't worry if I'm going to spend $4 or $6. I want to know just the price for 2 books.
Why is the graph even there then? Like,
Why do they bother showing the graph?
yeah.
I'm going to show you in a second. So let me show you something here. If I plot that point 5, 10 in here, 5, 10 right here, okay, there's a way to tell something's a function by just looking at the graph. We're going to get to that here in the very next problem. So hold that thought. We're going to get to that. Okay, so moving on, we're going to talk about the vertical line test. A test called the vertical line test can be used to determine if a relation is a function. The vertical line test states that a relation is a function if and only if a vertical line does not pass through more than one point on the graph of the relation. Okay, so here's a relation. And you can see that there's 2 points there, right? I really wish they would have spread that out. That's really annoying that they did that. But if you look there's actually 2 points, okay? So if you draw an imaginary vertical line through each one of those points, does any of these vertical lines hit more than one point?
No. Yes.
I know, it's hard to see. It's right here. It does. So this thing is therefore not a function. The x value of 10 is paired with 2 different y values. The 10 goes to like, I don't know, we'll say that's like 52, and that one's like 53 maybe or something. So it fails the vertical line test right there. Okay? That's why. Okay. Now, for letter B, I think it wants us to graph the example from earlier here. So let's see. Those numbers were 10, comma 150. So 10 and then 150. Okay. And then 16, 240. 16, 240. Man, I wish they would make these numbers just a little bit nicer for us, but they're not. So that's 225. So, I don't know, 240 would be like right there, I'll say. Okay. Actually, they already have them graphed for us over here, but all right, well, 17, 240. And then 2300. Okay. So again, let's draw the vertical lines through each one of these points, the imaginary kind of vertical lines here. Oops. Okay, like so. Okay. Do any of these vertical lines hit more than one point? No. So is this a function? Yes. Yes, this is a function. But we already established that on the last page, didn't we? So, okay. So let's do two more here together, and then I'll get you guys started on your assignment. Okay. So let's look at number 6. Use your imaginations. And we're going to see if a vertical line will intersect the graph more than once. Okay? So looking at number 6. Looking at number 6. Will any vertical line intersect that graph more than once? All right? So let's go to Mark. Will a vertical line ever intersect this graph more than once?
No.
No. So is it a function?
No. Yes.
Yes. Yes. It passed the vertical line test. So this is a function. Okay? And if you want, I'll draw on a few sample, vertical lines here. You can see any vertical line we draw is only going to hit that function, the relation, which is a function, once. Okay? And then let's go to Matt T.
It's not a function.
Number 7 is not a function. Yeah, so let's draw a vertical line right here. How many places does that vertical line hit? 1, 2. So not a function. What about over here? How many places does a vertical line hit here? 0. So if a vertical line hits 0 times, is that okay? It is okay. It doesn't matter. But it's where it hits twice. So really, your vertical line can hit no times, or it can hit 1 time, and it's still a function. But if it hits 2 or more times, like here, it's not a function. Anywhere, it's not a function. So if it only does it once, it's still not a function. Okay? Questions on any of that? And again, it follows from that same idea I was telling you guys earlier. This x value of negative 4, actually, I'm going to do an easier one. The x value of 0 here, what y value is it paired with? And number 7. The x value of 0, what y values is it paired with according to the graph? Positive 2, and where else? And negative 2, right? This x value of 0 brings us to a positive 2 and a negative 2. So the x value goes to 2 different y values there. And it happens all along here. Any of these x values you pick on the x-axis go to 2 different y values. There's your 2 different y values. There's 2 different y values. Okay? So that's the problem. The only place it doesn't happen is right here at 6. There's 1 y value. But that's at the vertex. Okay? Anywho, your assignment. Okay? And you guys got oodles of time here. So, you can get it done and go enjoy the football game tonight or just have a good weekend, But I want you to work on it in class right now. Starting on page 120, I want you to do numbers 1 through 7. Is that what you're saying, Matt?
Yeah.
I was going to just give you 1 and 2, but Matt really insisted on 1 through 7. So, I'm just kidding. I was going to do more than that anyway. So Matt was not. I'm not throwing Matt on the bus like that. That'd just be rude. That would be rude. Matt was like panicking. He's like, no. So, yes, you can get a drink of water. Yes. Nah, let's see. I'm going to... Goodness, okay. Let's do that one, and let's do then like number 9 13, 15, and 16 as well.
So I can do 8, 9, 10, or 11.
Okay. So 1 through 7, 13, actually 13, 15, 16, and I'd like to do like the 17 to the 22s as well. That's going to be super quick. You guys would like get through that so fast to be like, why did I even complain? I'm going to write them up on the board right now. Ready? So on page 120, page 120, numbers 1 through 7. Okay. Then 13, 15, and 13, and then 15 through 22. Okay. 13 and 15 through 22. Okay. Yes, I am satisfied with that.
Wait, what?
Ooh, okay, well, yeah. Yes, go ahead, Josh. Okay, so there are your numbers. Go ahead and get started on that. All right, if you get done, then you won't have any homework for the weekend. But you better get it done. Okay. Make sure you read the directions, okay? So for number 1, express that relation as a table, graph, and a mapping. And 2, 3, 4, and 5, 2, same thing. 3, 4, and 5, just to state the domain and range. 6 and 7, state the domain and range, and explain if it's a function or not. Don't worry about the interpreting in context part. You can forget about that. Okay, so you can scratch that part out if you want to. Get rid of the interpreting context, because I'm not really worried about that in this case. Seems kind of silly. Alex, question?
14, not to graph out the entire thing, because I'm trying to have the entire relation.
For 13?
Yeah.
13, it says,
No, 14.
you don't have to do 14. But it does say to express it as a mapping regardless of whether it's a function or not.
But like for 13, it's not.
So for 13, you still need to express it as a mapping,
Oh yeah, I did math.
but it's not a function. That's okay. You just say not a function.